All right, hi students, welcome back to 2.1C, and today we'll be doing first principle differentiation, basically the traditional way to do differentiation. If you weren't taught how to do using formulas, which I will teach you in like the next subtopic, which is under 2.2, differentiation techniques. All right, so it's getting late, so I'm speaking a bit soft for this video and maybe a few more. So I'll be teaching you how to do first principle differentiation, and it greatly relates to what I've taught you in the last lesson on the understanding on the what is gradient of tangent. Because for us to find gradient of tangent, remember I told you we need to find gradient of PQ first. We assume there's a line PQ right here. We look at this graph, okay? Assume there's a line PQ here, okay? But our end goal is to find the gradient of this line, this red color line, okay? This one that I'm highlighting here, that I'm drawing here. But the problem is we cannot find a gradient of tangent just that simply because we don't have two coordinates. We only have one coordinate. We don't have this coordinate. We don't have this coordinate. We only have one coordinate here. So what we do is we got to make Q, shift Q, bottom and bottom as it shift Q downwards along the slope until it reaches next to Q, next to P, until Q is just right next to P. So that the gradient between that small space is actually approaching the gradient of the tangent. Okay, but that one I explained in the previous video. If you don't understand, please go back and watch the previous video. Okay, it's not so important to understand the previous video. I forgot to mention that. They won't test you, all right, on how do you, what is the theory behind all these things. It's just for your understanding if you wish to know, which I've done in the previous video. If you don't understand, also don't be frustrated because I also took some time to understand before this. So if you didn't get it first time, doesn't matter. You can ask me questions in the comment section below, or you can just keep asking your teachers or whatever it is. All right. So today we'll be doing first principle differentiation. So first principle differentiation, right? There is a format to do. As we have learned in the previous video, what we want to achieve is actually delta y over delta x. This is the gradient of PQ. I just use the word PQ, okay, because you get what is PQ from this graph. PQ is this line, and tangent is this line. There are two lines you need to know, okay, as I repeat again. First one is PQ, second one is tangent. Okay, so this PQ, how can you make this PQ as close as the tangent? How? Is to make delta x approach 0. When delta x approach 0, the delta y, delta x, which is the gradient of PQ, will approach dy dx. And when you see dy dx, this becomes d, the d that we always write. It is actually gradient of tangent. This one is actually gradient of PQ. As I said, if you don't know what is PQ, watch my previous video, or you can just see from this graph. This blue color line is PQ. All right. So our idea is very simple. We want to find what is delta y, delta x first using first principle. Then we let delta x approach 0. Then we get dy dx, because this is our final product that we want to get, dy dx. Okay. And I repeat again, what is the difference between delta y, delta x and dy dx is that delta y, delta x is the gradient of PQ. Dy dx is the gradient of tangent. So how can gradient of PQ be something like gradient of tangent? How are they approaching each other? When delta x approach 0. As for why is it like this, you can refer to my previous video, okay? Or you can read the understanding here. I've written here already. I'm not sure whether you can understand or not, but never mind. Those are my own words. It's not like I didn't copy from a book. So if you don't understand or if there's a mistake, you can correct me. So let's try to solve, okay? How to solve this one is just by practicing. You must know the type of question. What you do now first is, when you see y and x, what you do is you let y become y plus delta y. Basically, this y become y plus delta y. Y plus delta y is equals to 2 minus 4 x plus delta x. Okay, what I do is basically this y I add a delta y, this x I add a delta x in a bracket, don't forget. You understand? So that's what I did. Okay, so what I do now is y plus delta y is equals to, expand everything on the right, 2 minus 4x minus 4 delta x. Remember, delta x is one thing, okay? Don't think delta as delta times x. No, it's wrong. It's delta x is one thing, not two things. You understand? Okay, let me write down here. Delta x is not equals to delta times x. You understand? Delta x is just like, treat it as one thing. Okay, I read it here. Okay, So what I do now is, because what we want to achieve is delta y divided by delta x. Okay, this is what we want to achieve, correct? So what we do now is we try to, we want to leave, our idea is to leave delta y on the left. We leave delta y on the left, then throw everything to the right. So delta y is equals to, we shift y over, okay? 2 minus 4x minus 4 delta x minus y. And you know that once you have reached this stage, basically what you do this step is you isolate. Basically what you do this step is you isolate delta y on the left. Then what you do next is, what you want to do is to replace y with this thing. Okay, because we know that originally the equation was y equals to this thing. So we can actually replace this y with 2 minus 4x. So delta y is equals to 2 minus 4x minus 4 delta x minus y. What is y? 2 minus 4x. How do I know? It's from this thing, okay? Because y equals to this thing. So this is y. So I can put it inside here. As I said, why you don't do anything with this delta y? Because delta y is one thing. It's like another unknown, like z or y. Or no, don't use y. Let's say something else. Maybe b or c, or you like it. Okay. So what we do is we try to solve for the left hand side, right hand side first. Delta y on the left is equals to 2 minus 4x minus 4 delta x minus 2 plus 4x. Don't forget, minus plus is minus plus is minus, minus minus is plus. This one, don't make mistake the sign. Okay. So what I have is delta y is equals to, can you see this is minus 4x, this is plus 4x? It's something like 4x minus x. Basically minus 4, then you plus 4, basically get you 0 because they are exactly the same term. Okay, minus 1 apple plus 1 apple gives you 0. Minus 1 banana gives you, plus 1 banana gives you 0. Minus 5 computers plus 5 computers give you 0. Minus 4x plus 4x gives you 0 as well. So this one go missing. 2 minus 2 will give you 0 also. Why is this 2 minus 2? Because this is plus 2, this is minus 2. So it's plus 2 minus 2, which is you gain 2, you lost 2. So it's 0. So there's nothing here. So you're left with minus 4 delta x. Okay. So now what I want to do is I continue here. Okay. This one is out of the story. Oh gosh. Okay. So now I want to get delta y over delta x. So we have I copy back minus 4 delta x. What I want to do is I divide both sides with delta x. So delta y over delta x is equals to minus 4. Delta x over delta x will give you 1, okay? Will give you nothing. Basically, what I'm doing, using maybe your teacher teach you this way, shift delta x over for division. Why? Because here is multiplication. So when you shift over, it becomes division. Or if you want to learn it correctly, mathematically, what you do is you divide both sides with delta x. Divide with delta x, divide with delta x. So this delta x will go away. So on the left, what you have is delta y over delta x is equals to minus 4. Okay, so now when you reach this stage, I want you to write one step. As delta x approaches 0, you have to write this step as it approaches 0. Why? Because now we want to change this to dy dx. Our end goal is dy dx. Dy dx is gradient of tangent. Gradient of tangent at a point. At one point, okay? Gradient of tangent at 1 point. This dy dx is gradient of pq. What is pq? Refer back to my talk. Or refer to our previous video. I'll use pq because it's easily understandable. Because I've taught in my previous lesson. So how do I make this pq gradient to be tangent's gradient? What I do is I let delta x approach 0. So when delta x approach 0, what you have is you have dy dx. You see, sure now I write dy dx already. Okay, so basically what you do is on the right hand side, if you see any dx, you substitute with 0. But you don't see any dx, right? So you just copy back minus 4. Basically, what to do from this step to this step, right? You substitute dx with 0. But there's no dx on the right hand side, so you don't have to substitute anything. The answer is actually negative 4. Okay, if you use shortcut rule, right, you know that dy dx in the next video I'll teach, not next video, probably the next video I'll teach you power rule. And how do you do power rule is basically you straight away know the answer is negative 4 already, which is same as this one. Okay, this is how you do first principle differentiation. What is your idea is to get delta y delta x. Once you get this delta y delta x, then you get dy dx. Can you see? Delta y delta x, then dy dx. Yeah, that's our idea. Okay, so we solve two more questions. Okay, y equals to 3y squared x squared. As I said, change the y to y plus delta y is equals to 3. X, change it to x plus delta x squared. Basically, what I've done is I've changed the y to y plus delta y, and x, y you change it to y plus delta y, x you change it to x plus delta x. If you might ask me, x, y equals square, doesn't matter. Change the x, then just basically replace the x with this thing, new thing. Just basically do it. And then if there's a square, leave it, doesn't matter. The format must be exactly the same. Y, family of y equals to 3 times family of x squared. This must be the same. Okay, you don't say, oh, let me do something like this. Y plus delta y is equals to 3. Oh, I don't know what to do. X squared plus delta x. No, it's wrong. Okay. What I want you to do is basically replace the whole x with x plus delta x. That's the idea of first principle. So as I said, expand firstly is to expand the right hand side everything first. Delta y is equals to 3 expanded x squared plus 2x delta x. How to expand this? You should work out yourself. How do I expand this? Is actually a plus b squared is equals to a squared plus 2ab plus b squared. This is the formula that I'm applying, plus 2x times delta x. You might want to ask me, okay, wait, I'll tell you something later. Delta x squared. You might want to ask me, oh, sir, can I times this x with this x to get 2 delta x squared? Cannot, okay? That is not the right way. This delta x squared must be in the bracket also. Okay, as I said, delta x, just treat it as something new. It's nothing related to x. Delta x is something by itself. Okay, you cannot multiply this one. Cannot multiply. Don't multiply. And then delta x squared. You might want to say, I write all the stuff here at the back. 2x delta x is not equals to 2 delta x squared. And then one more is delta x squared is not equals to delta square x squared. I don't know what this is also. As long as you treat delta x as one thing. Okay? I write the important things on the right hand side so you can note it down yourself. I hope it's getting more systematic after I provide this answer placed for you. Because before this, I simply throw stuff. Okay? So what you do on the left is you have what you do now is you expand the right hand side first. Y plus delta y is equals to 3x squared plus 6x delta x. Basically, I times inside every term plus 3 delta x squared. Okay, I just expanded everything. Okay, so what I do now is I remember until I reach this stage, don't forget, isolate the y. Isolate the delta y. I want to leave delta y on the left. I want to leave delta y on the left, so I must throw this y to the right hand side. So delta y is equals to 3x squared plus 6x delta x plus 3 delta x squared minus y. Okay, and this y, you know that it is actually from the question is 3x squared. So I don't want to write another step up, but if you want to write another step, you can. I will just straight away write 3x squared here. I replace with 3x squared here straight away. Okay, basically I replace with what I have here. All right. Then what I have is I use red lah. It's getting bluish. So you have delta y is equals to expand everything. You see now this is 3x squared, this is 3x squared, plus 3x squared minus 3x squared, plus 3 computers minus 3 computers, you have nothing left. Okay, then what you have left is 6x delta x plus 3 delta x squared. Okay, until you reach this stage, right, I want you to note something. Until you reach this stage, right, because I want delta y to be something delta x, so I can shift the delta x over for division, or I can divide both sides with delta x. You understand what I mean? So I want the delta x to be outside for the right hand side. Okay, I want the delta x to be outside on the right hand side. So what I have to do, there are 2 delta x here, no good. I want to factorize the delta x. See how I do it, So delta y is equals, the steps is always the same. So if you follow the steps exactly the same, you always get it. Okay, and this can go up to 4-5 marks. So please follow the steps and you should get it now. So I factorize the delta x out. So what I have back is, basically what I mean by factorizing is basically I'm dividing each term with delta x. So first term I divide with delta x, second term I divide with delta x. First term I divide with delta x, what I get is, you see, I get 6x. Can you see I get 6x? Or you know what? I don't want to write here, later you get confused. Basically, first term I divide 6x delta x, I divide by delta x because I factorize it out. So what I have is 6x inside the bracket. I hope you know how to factorize. Okay, I have 6x here. And then since it is plus, here is also plus. And then this term now you divide with delta x. Here got delta x squared, you divide with the delta x, you're left with 1 delta x. So you have 3 delta x. Okay? Or you want to see it, why? Is because 3 delta x squared divided with delta x. You see delta x and delta x exactly the same thing, same base, different index, different power. So what I do is 3 delta x. I can minus the power because it's division. 2 minus 1 gives me 3 delta x, power of 1. I don't have to write the power of 1. Okay, so I get 3 delta x here basically. That's what I'm trying to explain to you. There are many ways of looking at this. Some people might look at it this way. 3 delta x times delta x, because delta x squared is basically delta x times delta x. Then I divide with delta x. So I can cancel one of the delta x because it's multiplication. So I can actually cancel terms. It's very fun. So I'm left with 3 delta x only because this one is gone. Okay, you can look at it this way also. Depends on how you look at it. Or you look at it as law of indices also can. That's what I told you in the first method to do it. Okay, so now I've gotten this thing, which is very nice because now delta x is multiplying this bracket. So I can shift this delta x over for division, or I divide both sides with delta x. What I do is I divide by delta x, I divide with delta x. So what I get on the left hand side is I'll get delta y over delta x is equals to delta x divided by delta x will give you 1, not 0 or 1. Same thing divided by same thing is 1, not 0. 6x plus 3 delta x. And remember I told you, how do you change delta x to dy dx? Delta x must approach 0. Okay, when delta x approach 0, what will happen is you straight away dy dx already. When you have delta x approach 0, you have dy dx already is equals to, see there's any delta x on the right hand side. Yes, there is. So I have 6x plus 3. Delta x you substitute with 0. That's it. That's the main point of what we're doing now. We want to substitute delta x with 0. So what we have is just 6x plus 0, which is 6x. That's the answer for dy dx. This is actually the gradient of tangent. Basically, what we mean when we get dy dx, right? I'll explain again in the next few videos, right? But actually, what it means is that you have a curve. Okay, this curve, right, has a gradient of 6x at any point. For example, this point, what is the gradient? You might want to know. What is the gradient here? I know the gradient of this tangent is, because dy dx is gradient of tangent, don't forget it, gradient of tangent, basically how steep the gradient is. Gradient of tangent. So I know this gradient of tangent is 6x. If you know the x value, right, the graph, if you know the x value, just say 8, right, you should really know the gradient already. Is 6 times 8 is 48. Okay, for example, I want to know what is the gradient at this point for this curve. I draw a gradient, I draw a tangent. I'm finding the gradient of this tangent, okay? The gradient is, let's just say, we know it's 6x. Because this is gradient of tangent, okay? We have found the gradient function is 6x already. Okay, so if I just include the x value at this point, maybe -2. I have 6 times -2 is -12. So I know that the gradient of this line is -12. And I want to mention something first about gradient. This thing don't have to worry first. I'm going to teach you in the next few videos. What is important I want to know is that gradient, when it goes up, is a positive gradient. When it goes down, goes up is a positive gradient, goes down is a negative gradient. This one is very important that many people do not know. You see, what is the importance of knowing this? Exam, you won't get marks in this in exam because exam won't ask you this thing. But what it can help you is that it can help you check answers very quickly. You are so sensitive to answers. Once you see, oh, I got my gradient. For example, I have this line. Oh, my gradient is 2. I straight away know it's wrong because when you're going downwards the slope, the gradient cannot be positive. You understand? So that is what I'm trying to say. That all these small tricks, right, wouldn't help you to score maybe better, but it would definitely help you to make sure your answers help you spot things quicker and help you correct your mistakes faster. This is what I'm trying to say, which is very important, which is tend to be the determining factor whether you get very high marks or whether you get high marks or whether you don't get high marks. It's the determining factor in many ways, okay? So this one I don't want to rub lah. This one I leave it here for you. So this is another important trick I want you to know. This you can write down as well. All right, this one belongs to the top lah. So I've done 2 questions already. Getting harder and harder. I'll do 1 more question and the rest you can do yourself. I'll do now what happens if you have x in the denominator. It's getting tougher, but never mind. It's the same process every time, okay? What you do is y plus delta y in the bracket is equals to 4 divided by x plus delta x squared. Basically, replace x with x plus delta x in the bracket and replace y with y plus delta y in the bracket. Once you have done that already, what you do now is, as I said, expand the right hand side first. Y plus delta y is equals to 4 divided by, expand it, you have x squared plus 2x delta x plus delta x squared. As I said, x can times this, x or not, cannot. Why cannot? Because treat delta x as one thing by itself. You cannot multiply. It's something like x times y. You cannot do anything, okay? It's xy is xy. You cannot, don't times this x together. I repeat now, because I'm scared later suddenly you jump to this question without looking at the question above. Then you might not know. And you say, oh, this probably never teach. Okay? So better watch fully. I hope that you can watch fully, not because of anything, it's just because that I tend to say things progressively. Wait a minute, there's something missing here. Okay, nothing. Okay, so what I want you to do now is the same steps again. Shift the y over. What I get is x squared plus 2x delta x plus delta x squared minus what is your y is 4 over x squared. Okay, basically I'm first why is this? Because I bring y over for minus, right? I bring y to the right hand side for minus, so I get minus y. And then I know y is actually 4 over x squared. So if you see, right, the question is always the same one. The steps is always the same one. You get me? So what you do is you just follow the steps. Then you just settle the right hand side, just arrange the right hand side. So what can you do on the right hand side is equate the denominator first. Let me see what we can do. The only thing I can think of is equate the denominator first. So what you get is x squared plus 2x delta x plus delta x squared. Okay, how I equate the denominator? If you have 2 over 3 minus 5 over 4, what I do is basically, what is the denominator? I can equate them to become, I just multiply these two numbers together, 12. I don't know if you remember or not. Or what your teacher tend to teach you, I think is usually times 4 times 4 times 3 times 3. So you have a common denominator of 12. So you have 8 minus 15. I'm using the same trick here. Okay, I just multiply the denominator with this one and this one. Okay, then on top, what I have is on top, I have 4x squared minus 4 times x squared minus 4 times this whole thing. Okay, look at this thing for the same thing. Minus 4x squared plus 2x delta x plus delta x squared. Yeah, I have this thing. So delta y is equals to what? Okay, if you expand the top, you have 4x squared minus 4x squared. Open the bracket basically. The minus 4 times this thing gives you minus 8x delta x. Minus 4 times the back thing gives you minus 4 delta x squared divided by the bottom thing, which is just leave it like this so it doesn't matter. X squared plus 2x delta x plus delta x squared. Don't be scared of the complication here, okay? Don't be scared of the complication here. Why? Why don't be scared of the complication here? Is because later when we substitute delta x with 0, a lot of things will disappear and it will look beautiful later. Okay, so we move up here. So we have delta y on the left hand side. So on the right hand side, you see this is 4x squared minus 4x squared. This, okay, in front is plus, in front is minus. So when you have plus 4 minus 4, it gives you 0. Okay, I give you 3 balls, you give me 3 balls, you're left with none. 0. Okay, when 4 minus 4, exactly the same thing, only you can do it. 4x squared and 4x squared, they're exactly the same. So you have 0, cancel. So what I have is minus 8x delta x minus 4 delta x squared divided by what? Divided by x squared plus, I just copy only, 2x delta x plus delta x squared. Okay, so now what I want to do is the bottom, okay, you see, am I ready to substitute delta x? You ask yourself a question. Am I ready to can I actually bring a delta x over for division now? Is there any delta x I can bring over for division? And you must know, when I divide with delta x here and I divide with delta x here, basically dividing with delta x basically means you times with 1 over delta x lah. As I said, you divide by 2 is actually equals to times 1 over 2. Don't forget that. So am I ready? So when you times 1 over delta x, right, you want to cut this delta x with the top delta x, okay? So how can I cut? I have to factorize the delta x on top first. I have to factorize the delta x on top first so I can cut later. So that's the idea, okay? So I have to factorize the top. Bottom, I don't have to care first. You see why later. Delta y is equals to, I get the delta x out, so I factorize what I get. The first term divided by delta x, what I get is minus 8x only. Because delta x divided by delta x gives you 1. So I'm left with negative 8x. Then minus y minus, where this minus, 4 delta x squared divided with delta x. This delta x squared, this delta x, so you minus the power, you're left with 1 delta x only. 4 delta x divided with x squared plus 2x delta x plus delta x squared. Okay, so now you see now, once I divide with delta x on the left, once I divide with on the right, divide means I basically times 1 over delta x, the same thing, because bottom has too many things, so I don't want to write next to the bottom. So what I do now is I can cancel the delta x. Why I can cancel? Now you might ask me why I can cancel. Sometimes you cancel, sometimes you say cannot. Because now this is multiplication, so I can cancel. It's not multiplication. Okay, so it's multiplication, I can cancel. As long as top cancel bottom, top cancel bottom. Okay, here got nothing to cancel, don't have to cancel. So top cancel bottom and it's multiplication. So I cancel them. So what I'm left with, delta y over delta x is equals to minus 8x minus 4 delta x divided with this whole chunk, x squared. Why I don't care about it, later you see why. Plus 2x delta x plus delta x squared. Okay, now what I do is, once I've reached this stage here, right, what I want to do is I want to, as delta x approach to 0, remember, always you want to do this step. This is like the transformation step. It's like a transformer. You want to transform to something, you must maybe eat some food. This is the food that you need to take in. Okay, you must write this step down as delta x approach to 0, then only you get dy dx. Dy dx is gradient of tangent. As I repeat many times, a gradient of tangent at one point. You can memorize it now first. As I teach you gradient of tangent later on in the next subtopic, I'll explain to you further. You can memorize it now first. Dy dx is gradient of tangent at a point. Okay, gradient of tangent at a point. And then delta y delta x is basically gradient of pq. What is pq? Refer back to my previous video. All right. So dy dx is equals to what? Dy dx means you got to substitute delta x with 0. So all the delta x you substitute with 0. This has delta x, this one is delta x, this is delta x. Everything will become 0. So you see, very nice. So minus 8x minus 4 times 0 divided with x squared times x squared plus 2x times 0, because delta x becomes 0 here already. Then you plus delta x is 0 squared. So it's also 0. So what is your answer? You have minus 8x on the top, because this one will become 0. Divide with what? X squared times x squared. This is 0, this is 0. Because 2x times 0 is also 0. Plus 0, 0 squared is also 0. Everything will become 0. You see, isn't it nice? So what I'll get is minus 8x over x squared times x squared. Okay, because this 0 don't have to write. What I'll get is minus 8x over same base. What you do is you add the power, because it's multiplying between them. So you add the power, what do you get is, at the power you get x power 4. Okay, so now I can this x power 1, this x power 4. So what I get is, my answer is, I can cancel actually. I can cancel. You can cancel this x, then once you take one x away, this one left with 3. Okay, so you're left with minus 8 over x. Let me check, is it correct or not? Minus 8 over x. Yeah, the answer is correct. This is the correct answer. Okay, you see, so you don't be scared of the denominator, which is so complicated. Once you put dx as 0, a lot of things will disappear. Okay, so I want to give you some advice on this. Our first principle is basically always the same thing. I've given you, I think, enough questions of kinds already that you can do already. Okay, first one is when you have x only. Second one is x squared. Third one is the bottom has x squared. Bottom has x squared is a bit tougher, but you just follow my steps. Just follow my steps. Make sure you see how I do already. Then you cover the book. You are able to do this thing with yourself. Visualize the steps out nicely, or you can write it down nicely. Every step perfect until the end. And you can do it without even referring 1 second, not even 1 second of referring. Cannot be, see, forgot, what is it? Cannot. Without referring, once you're able to do, super, you are ready to go already. You're set to go. You understand? So what I want you to do is, it might seem hard now, but it doesn't matter. First principle, they seldom ask. I think in 10 years, they ask once only. So you don't have to be scared of first principle. All right? So this is about first principle. Yeah, nothing much really. So I'm done with actually 2.1. Chapter 2.1, I'm fully done. Remember what I've covered? I'll give you a little summary. First one is the limits. Remember limits, you have two kinds of questions. One is the normal type of question where you factorize, you cancel the denominator so that it won't give you a zero denominator. Okay, because if you straight away substitute the limit, you get zero denominator. If you're not sure what I'm mentioning, refer back to my first video on this 2.1 part 8. So you want to avoid denominator to be zero. That is why I factorize and I cancel the denominator. Because when the denominator is not there, it cannot give you zero anymore in the denominator. And that's what we don't want. So we factorize and we cancel. Don't forget, that's the first technique. Second technique, and I say I'm summarizing for you guys who have actually already learned. I'm not reteaching because I'm going through just very quickly. Okay. The second technique is when you have x approaching infinity. When you have, remember infinity, you see question number 2. When you have question approaching infinity, you divide top and bottom with the unknown with the highest power. If the highest power is x, divide with x. If the highest power is x squared, divide with x squared. Okay, not very hard. And then we move on to understanding of what is actually gradient of tangent. This one, you refer back. I don't want to touch this on this point. Later, I confuse you even further. This one, if you understand, understand. Don't understand, never mind. If you don't understand, what I want you to at least know is gradient of tangent is dy dx. Okay, gradient of tangent is dy dx. Here, delta y over delta x is actually not your gradient of tangent. It's actually gradient of PQ, gradient of a line. Okay, PQ is this line you can see here. And then dy dx is only a gradient of tangent. That's why in our first principle just now, right, we found delta y over delta x first. Then we do something special. We assume delta x approach to 0. Then only you have dy dx. You understand? So it all happens like this. First you have delta y over delta x. Oh, I don't write it here. I write it in the next page here. So what you have is you have delta y over delta x. Then you as delta x approach to 0. Then you have transformed it to dy dx. Okay, what is delta y delta x? Gradient of PQ. Gradient of a line of PQ. What is the line? Is PQ. It's not the tangent, not tangent. Delta y delta x not tangent. Okay, tangent is actually your gradient of tangent is actually your dy dx. Okay, but they seldom ask this one. How do you transform this one to this one? Is you need to make delta x approaching 0, which is what we have done in the first principle. So if you don't understand, at least know the technique how to do it, right? So I think that's all for this first part. They seldom ask for the first part, I would say. The more of it is the next 2.2 onwards. 2.2, 2.3, 2.4 is their favorite questions. They love to ask all kinds of funny questions you can appear there. But it's not hard. It's really not hard. It's not as hard as this. I would say it's easier than this. All right? It's easier than first principle. People think, oh, I'm so scared because their seniors say this, say that, because it's passed down that way. Oh, Add Math differentiation is so hard. Okay, don't make others change what is supposed to be easy for you. Okay, don't just because people say it's hard, then you feel it's hard, even though you might think it's easy. All right, but it's good to learn as though as it's hard. Means not to be arrogant when you learn. Always tell yourself, okay, I'm learning it for the first time, even though I've done like 100 questions for each topic already. But always when you try to attack the question, don't be so impulsive. Don't, I know straight away. Do no. Read through the question, what they want, what they have given you, and think carefully first. What is the steps to do until your final answer? Then you work. That's the correct way to do it. Not, oh, I'm so ganjiang. You know, in Chinese, call it ganjiang. Then after that, we straight away attack. Then you do the whole thing, and you realize you're not answering the question. That happens to me last time. No joke, you know. I always see the question. I assume the question is what I think it is, you know. Then I straight away do what I want. Then I read back the question. Oh no, they're not asking what I'm doing. And then, even though what I'm doing is not wrong, you know, it might be some other questions, but they're not asking that. Okay, so I don't want you to be that way. I want you to stay calm. The better you are, the calmer you are. All right, I don't want to make this video too long. So I think I'll end the video here. I hope you actually learned something through this differentiation. I would say the front part of the chapter the front part of the chapter. I'm done already. I covered in 2.1. So I wish you good luck when we reach the next subtopic on differentiation techniques. Okay, I'll teach you a few rules. I'll teach you product rule, power rule. I don't know, power rule first, then product rule, quotient rule, chain rule. And you must learn how to do all of them. And there's one combination rule, the chain power rule, power chain rule. I don't know why you call it power chain rule. So that is all for this video. I'll see you in the next video. All right, happy learning. See you in the next video. Ciao.